So we were discussing about the different types of topologies. In that we discussed about the ring topology in the previous class. We will again discuss in detail these things. Okay, uh, and also about the star, bus, mass, tree topologies we have covered. Right. So any doubt in that?
No, sir.
Okay. So as I was discussing about the star topology, I like to tell you that generally I told you that there can be two possibilities. Um, we can have a hub here and the stations are connected to this hub, right? So any station wants to send. So this hub can be a passive hub. So that means it will be simply a connector, or it can be an active hub which is just as a repeater, which acts as a repeater, uh, or it can be a switch, right? So let me just take an example of a active hub. So what happens basically in a star topology, we usually have a hub, a central hub to which all the stations are connected. So any transmission from a particular station, right? Once A transmits, A like to transmit to C, right? So this hub either works, as I said, in an active hub, works in a broadcast manner. So if you remember bus LAN, in that also a transmission made by a particular station will be received by all other stations connected on the LAN. Similarly, here also, if I talk about this hub, which can be an active hub, uh, so a station A transmits to C, so it will first go to this central place, to the hub, and then hub broadcast it on all the outgoing links except the incoming link, right? Except this link, it will broadcast it on all the outgoing links. So the transmission was intended for station C, but it was also received by station B, right? So there can be two issues other than that. The failure of this hub may result in complete uh, will completely stop the communication. Other than that issue, right, there can be two more issues. First issue is that the stations who will transmit, right? So this issue is a valid one and it lies in all the topologies which we discussed. Who will transmit first and how the priority of the stations will be decided, right? Because as I told you that some of the stations may have larger data to send, means they are having more uh, data for transmission, right? Particular node, see, every station has its different requirement. Some stations may be greedy, they have lot more data to send, while the other stations may not have any data to send, right? So depending on the type of traffic generated by a particular node, right, this priority is decided. As I told you that in the previous class that this priority, like what kind of traffic is generated by a particular node. A node can, if it is a real time traffic generator, right, if it is generating traffic in the real time, so then obviously that should be given more preference, right? And the packets leaving from that particular station should be treated in the network also with some priority, right? So basically, all these things happens in the network, right? Now nowadays, when we are talking about 4G and we are at the doorstep of 5G, right? 5G deployment. So you can imagine that the data rate will be very faster, right? And as these things are increasing at one side, the other side our demands are also increasing. पहले हम लोग नॉर्मल स्टैंडर्ड एचडी स्टैंडर्ड डेफिनेशन में मूवी देखते थे, अब हम लोग एचडी में देखते हैं, फिर ब्लू रे में देखेंगे. So our demands are also increasing because the demand for the higher bandwidth and faster data rate, right? So this demand is keep on increasing. So based on these demands, the stations are also characterized, right? So who will transmit, right? And how the priority of the stations will be decided, that which station should be given more priority, which station should be given less priority. So that will be based on the traffic generated by that station, right? So all those things we will discuss, but this question lies that when there are many contenders, which station will be given a chance to transmit. So this basically taken care by a protocol named medium access control, MAC. So MAC protocol decides that that who will transmit first, right? Then another question, like the collision possibility. See, you can see that suppose if I have another station also D. So A, it may happen that A is transmitting to B and C is transmitting to D. So all that transmission goes into this hub and get collided, right? Because so there should be a provision that the collision can be avoided, because if collision occurs, it results in subsequent collisions and results in complete network jam, right? So how this issue is to be dealt with to some extent by providing a two different wires to the stations, right? That if there are two different wires, one for transmission and one for reception. So if a station is transmitting on this line, it will receive on the other line. So the possibility of the collision is avoided to some extent, but the collision may happen inside this hub, right? Suppose if A has also transmitted to the hub, C also has transmitted to the hub, then the collision may occur inside the hub, right? So that is being taken care by some collision presence signal or something that we will see how this collision is avoided. Okay, so to some extent this we have provided a bidirectional path, one for transmission and one for reception. Two links are provided so that the possibility of the collision is reduced, but the collision still can happen inside the hub, right? But if I say about the throughput of this topology, can anyone say what will be the throughput of this topology? If this link is of 10 Mbps, right? If the data rate is of 10 Mbps, can you say what will be the throughput? Huh? Akash Kumar? Akash Kumar? If you guys don't respond, then तब ठीक नहीं होगा. बोलो. अमोल श्रीवास्तव? अमोल? अमोल श्रीवास्तव? बोलो। अतुल कुमार पांडे।
सर 20 MB।
20 MB कैसे?
सर 10 MB plus 10 MB. So in 1 second 20 MB data can be transferred. So because of 2 wires.
No, but at a time, like suppose when A will transmit to C, but at that time B should not transmit to D, na, or any other transmission should not be in place. Otherwise, what will happen? There may be a collision, right?
Yes, sir.
So at a time you will be transmitting only one station is transmitting at a rate of 10 Mbps. So how the throughput can be increased? By replacing this repeater, this active hub by a switch. So if we replace it with a switch, what will happen? It will increase to n into 10 Mbps. So if n number of stations can have access, because at the same time A will send to how the switch works? Switch will only activate that particular link. Suppose A is transmitting to B, so 10 Mbps it is transmitting and receiving, and similarly at the same time C can transmit to D, right? Similarly E can transmit to F. So at a time n number of stations can transmit at a data rate of 10 Mbps. So that is how the throughput is increased by n times when we replace this hub with a switch. Moreover, that unauthorized access of the data packet is also removed, right? Because now the transmission which is intended for B will be received only by B only, not by C or D, right? So that issue is also resolved, right? So I'm just saying about, I hope, is there any doubt in this so far? Okay, so if I say about the medium access control, can you say what is a medium access control? Can anyone say what is a medium access control? See, medium access control works on two words, where and how. See, what is medium access control? We have discussed a bit, right? And these are the three broad categories in which this MAC can be classified, right? And then we will see different schemes falling under these cases. Can you say what is medium access control? We talked about it so far that the medium access control is that to control access over the medium, to provide controlled access over the shared medium, right? So when we say who will transmit, so who will decide that who will transmit? So we need someone there to guide that you will be transmitting first, then you will be transmitting, right? So the question arises that where it should be applied. There can be two possibilities. Any control action which you want to apply. Okay. So control can be applied, right? Either in a centralized manner. Centralized manner, or it can be applied in a distributed manner. Can anyone say what is this? Distributed and centralized? Okay, so in the team, we have to. Ashish Kumar, can you say? Experiment. Okay, by next Wednesday. Ashish Kumar. Okay, by next Wednesday, you have to write it on A4 page. Huh? Or any page. Okay. बोलो सेंट्रलाइज कंट्रोल का कोई एग्जांपल दो. And you have. Yes, Suraj. बोलो.
You can write. I told you, any page, any copy. Okay? You can write.
रोहन, तब फिर तुम लोग ये सब्जेक्ट लिए क्यों जब नहीं पढ़ना था? दूसरा सब्जेक्ट ले लेते. हाँ? Why you guys have taken this subject when you are not interested?
My opinion is use.
So if you are not interested, you may change it. अभी भी चेंज कर सकते हो, मेरे को कोई प्रॉब्लम नहीं है.
Okay, no problem, no problem. Okay, circuit take a circuit diagram, observation.
कार्तिक राय, कार्तिक राय.
White page. For writing, you can use the rule page.
एटलीस्ट बोलो तो, नाम तो बोलो, नहीं तो हम एब्सेंट करते जाएं सबको.
Save your experiment
बोलो.
with your name and roll number underscore experiment number.
अभिक सेन.
Yes, sir.
Okay, my next.
Can you
Sir,
say
I'm
what?
Karthik Rai. Can you hear me? Sorry, my mic wasn't working.
Can you say what is centralized and what is the distributed control? जैसे अभी हो रहा है, it is distributed now, right? So everyone is responsible for conducting the exam of their own course. So that is distributed. So centralized has got its own advantage and disadvantages. Can you say what is the advantage and disadvantage associated with the centralized scheme?
We can perform if two objectives are there, we can perform within 1 hour. Okay. So nothing wrong in that.
See, the main advantage of centralized scheme is that high level of coordination.
For this one, and it's not required.
Coordination, high level of coordination can be achieved in a centralized manner, right? There will be no conflict among the peer nodes, right? High coordination can be expected in centralized scheme, and there will be no dispute between the peer entities, right? But the centralized scheme has got a disadvantage, that if the centralized node fails, everything goes, right? While distributed has got its own strength, right? Own strength means distributed में क्या है, that some of the nodes have taken a decision that what they are going to do, that how long they are going to, they have made their own decision that I will be transmitting, station A will be transmitting for 10 minutes, station B for 5 minutes, station C for 8 minutes, like that they among themselves have decided. So that is a distributed control, and this provides more flexibility in the system, right? Distributed one, and it is not like that failure of a single node will disable the entire communication. So that is also not there. But distributed has got a disadvantage that in case of a distributed approach, can you say any disadvantage of the distributed approach? बोलो कार्तिक, कुछ बोल रहे हो?
Sir, there might still be problem with the coordination. Like two stations might try to transmit, or might try to schedule at the same time.
Yes. So, but distributed still is good when we say for a larger network, when we have to deal with a larger network, distributed control has got its advantage, right? So this is, I talked about where to apply this control. Now the question comes that how the control will be applied, right? There can be a synchronized approaches, there can be asynchronous approaches. So can you say that the medium access control can be a synchronous one? We cannot have the synchronous approaches because you do not know the characteristic of a station. when the station will transmit, when the station will not transmit. So synchronized approaches are not useful in this case, especially in case of a computers, right? But asynchronous approaches like these are asynchronous approaches reservation. जैसे पहले क्या होता था BIT में, if you may not be knowing, earlier when the internet facility was not given in the hostel, so earlier there was only one system used to be there in the common room. One or two system used to be there in the common room with internet facility. So there we used to have a time slot, like reservation, like you have to book your slot first. So similarly, here also reservation means like we book our ticket, train ticket or flight ticket before proceeding for any journey. Similarly, the reservations are made. So stations do reserve their slots, right? That this particular station will transmit on this much duration, or so the maximum duration, either the reservation can be given for a maximum duration or the maximum transmittable unit, okay, that the maximum amount of data that you can transmit. तो जैसे पहले हॉस्टल में भी होता था, तो आपको जो इंटरनेट, बच्चों को जो इंटरनेट दिया जाता था, तो एट दैट टाइम द इंटरनेट वाज अवेलेबल ओनली फॉर हाफ एन आवर और 100 MB of data if you have utilized in that period. So there was a bar on that. So similarly in reservation also, the stations can be applied either in a centralized manner or in a distributed manner. The stations can reserve their time slots, right? And based on that, either based on the based on the duration or based on the maximum amount of data that they are transmitting, okay, that slot can be provided. Can you say any example? You have studied such schemes, reservation schemes. Can you name any of the such schemes? You must have studied in the digital communication. हाँ, और data communication में भी पढ़ा होगा. Can you name such scheme? Anyone? Ayush Paul.
Sir, I am not remembering now.
Can you say what is the time division multiplexing? Can you say?
The signals are distributed into time slots.
So time slots, na? So you divide the medium into time slots. Each station will transmit into their own time slot, right? So that is an example of a reservation scheme. Round robin. Can you say what is round robin scheme? Round robin.
Sir, a particular system is given some amount of time and then it is taken away from that and it continues, like it will come back to it after it has given time to each of the system.
Right. So this scheme can also be applied in the centralized manner or distributed manner. Each station will be given a chance in a round robin fashion, right? So once a station finishes its job, it will pass the control to the next station downward in its to the next station in queue, right? So every station will get an opportunity to transmit once, then the second round of transmission will implies, right? So this is how the round robin system. This can also be applied on a centralized or distributed one. And the third approach, which is widely used, that is called as a contention or random access, right? So in these two schemes, the stations transmits when they have data, right? They check, but in a contention scheme, which is also called as a random access, right? So here the stations contend for access. वो लोग आपस में एक दूसरे से लड़ते हैं और जिस स्टेशन के पास भी डेटा होता है that station transmits without thinking that it may collide with the other stations, right? So these stations contend for access, and the stations using this contention mechanism, they contend for access and with each other, and whoever is having the data, it will immediately transmit once it finds the medium is idle, right? Uh, it will not wait whether the other station is transmitting or not. It is highly not bothered. So this type of is called as the greedy one, right? So stations transmit immediately, contention scheme. So there are many protocols which are like CSMA, CSMA-CD, CSMA-CA. They all fall under this category of contention scheme. So we will see it in detail, those protocols, MAC protocols, right? Any doubts so far? Okay, so now let us discuss about the topology. Choice of topology depends on reliability, expandability, and performance. Reliability means, can you say what is reliability?
Redundancy.
Like how many nodes it can support, right? And still it is reliable. ऐसा नहीं है कि वो काम नहीं कर रहा है या there is an issue. So reliability of topology means it is not purely, see, these things are not purely depends on the topology itself. It depends to some extent on the transmission medium, MAC technique, wiring layout. So it depends on the many other factors when we talk about. Okay, so choice of topology also depends on the expandability. Like if in future number of users increases, right? So in that case, whether, or suppose company has got its extension plant, so whether the same facility, the same topology can be used further, right? So expandability and performance, like, so if the number of users increases, whether the performance of the LAN decreases, or whether it provides the same performance, the performance remains the same. See, performance means throughput, right? How many packets gets dropped, how many packets are successfully received, right? Reliability is related to the failure, right? So generally you have studied different types of transmission media, wired or wireless, okay? But when we talk about LANs, local area network, we will talk about the three types of transmission media. One is a coaxial cable, twisted pair, okay, and optical fiber, right? So you know that twisted pairs, like the telephone wires, you have studied twisted pair, shielded twisted pair, unshielded twisted pair, category 3, category 5 twisted pair. So basically twisted pairs are good when you have to they can provide higher data rates for a smaller distances, right? When you have to cover a smaller distance, you can use them for providing higher data rates because they are cheap, right? And but if you, even in ring also you can use, twisted pair can be used in star topology and ring topology, because ring topology is what, also a dedicated point to point links are there between the stations. So you can use star topology there, sorry, this twisted pair there also, because if the stations are not very far apart, you can connect them using a twisted pair, and you can get a very good, not very good, but means fairly fair data rates. You can achieve fair data rates over that, right? But if you like to have a higher data rates, you want to go for higher data rates, and you also like to cover a larger geographical area, then in that case, we can go for a coaxial cable. So coaxial cable we use like in our cable TV. You have seen that we use cable TV. So coaxial cable is again classified into three types basically. We say a baseband coaxial cable, broadband coaxial cable, and carrier band, which is just a abridged form of both baseband and broadband. You know, can you say what is the difference in baseband and broadband? Broadband connection everyone is using. I suppose you people are using the broadband connection at your home. So can you say broadband? Can you say about something about broadband? There is a baseband coaxial cable which can be used for few kilometers, right? And this can be used for a larger for a longer range, right? This baseband coaxial cable uses digital signaling, right? It is only suitable for digital signals. And this baseband coaxial cable में क्या होता है, the entire bandwidth is consumed by one signal. One signal means only one particular channel can only be seen in that. No FDM is possible. जैसे आपका टीवी में क्या होता है, we watch many channels at the same time, but in a baseband cable only a entire bandwidth is consumed by the single channel or one signal, right? No FDM possible. It is bidirectional in nature. This baseband coaxial cable, the data transfer is bidirectional in nature, and it uses preferably bus topology, right? It is suitable for bus topology, while broadband coaxial cable, which uses analog signaling, right? It uses analog signaling and multiple. Here in this case of broadband, your FDM is possible. Multiple channels are possible for audio, video, and data. Everything is possible in case of broadband, but it is unidirectional. I will come to this point why it is to be unidirectional, right? And it supports both kind of bus and tree topology. It allows analog signaling, right? It allows analog signaling, so that is why it is called as an abridged form of this baseband and broadband. So if we say about like the topology wise, that we can use in the bus topology, we can use baseband coaxial cable, like which we use in the Ethernet LAN. आप लोग जो LAN connection में आप use करते हैं, that is basically a baseband coaxial cable, and but it is difficult to work with coaxial cable as compared to twisted pair, as I told you earlier. That because there will be an issue when during the installation of the stations, because the stations are to be installed physically, interfaced on the cable through a tap, and from the tap there is a drop line that connects the station in a bus topology, and there's an issue when you rerouting of segments, to perform rerouting of segments, that is also an issue, right? Because if you have to perform the remove some station and then connect it, there it will be an issue. So on a coaxial cable we can achieve higher data rates over larger distances as compared to the twisted pair. On the other hand, if we are discussing as per the topology, so twisted pairs are used, can be star topology and ring topology, both can support that, both can use twisted pair. And as I say, the ring topology is suitable with twisted pair, coaxial cable, OFC. So if you want to have a very higher data rates, you can go with optical fiber, which is having a very higher bandwidth, as you know, lower electromagnetic interference, EMI, less EMI. So ring topology can also be used in OFC, and that ring topology used with OFC is known as ABDDI, which is a very high data rate scheme, right? Fiber distributed data interface. It's a ring topology only that uses optical fiber. It provides a very high data rates, okay, over a larger distance. And so, and it supports different types of data also, right? So if I have to say which topology is suitable for which type of transmission media, you can see that at the left side I have a transmission media, and at the right side I have a topology. So you can see that the twisted pair can be used in ring, bus, star, and baseband coaxial can be used in ring and bus, and optical fiber, ring, bus, star. Broadband coaxial can only be used in bus entry, both bus entry, and wireless can be used in ring, bus, star. Now the question arises, why the baseband coaxial cannot be used for tree topology when it is used for bus? Why not it is for tree? Why not for tree?
So maybe because the entire bandwidth is consumed by one signal, so the other branches won't get to communicate.
See, digital signals are more difficult to propagate on each branch of a tree, right? So when you are, because in baseband coaxial cable you will be dealing with the digital signals, right? So digital signals, propagating digital signals at each branch, different branches of the tree is very difficult, right? We will talk about it, okay? So because now we will talk about bus tree topology. So if I talk about bus and tree topology, data can collide if more than one station on the land attempts to transmit. That we know that if multiple stations attempt to transmit, there will be a collision. Can you say what is that? Signal balancing. See, there are when we talk about a point-to-point link, right? Let us first talk about the point-to-point link. What is signal balancing? So you have a. Can you say what is SNR of a signal? Signal to noise ratio of a signal. That signal power divided by the noise power, right? So when we say about signal power divided by noise power, so signal power should be sufficiently high to so that the noise effect is not that it's not that so that the noise should be suppressed, right? The signal power should be such that the noise is not very much effective. So what should be this signal to noise ratio, right? Because your signal is traveling in the on a particular link. As you know that when the signal travels on a link, the signal strength falls exponentially, right? Because of the noise and distortion, right? So the signal strength falls off. So what, see, the question comes that what or how much signal strength should be there, so that once it is reaching at the receiver should recognize it properly, right? So if the signal strength is not very high, right, and it becomes weak further while traveling in the network, then and once it reaches at the destination is unable to recognize it because of a high noise power. So that should not happen, right? And the second thing, that the signal strength should not be too high, right? It should not be too high, because if it is too high, what will happen? It will introduce the non-linearity in the receiver circuitry, and because of that, what will happen? Delay distortion occurs, those things occurs, right? So what should be the label of how to set this signal power label, right? It should not be very high so that it introduces the non-linearities in the receiver circuitry, or it should not be too low so that the receiver can recognize it properly, right? So as far as we are concerned only about a single link, single point-to-point link, we can manage it, right? We can control it. But when we talk about a multi-point configuration, where there will be n for n number of stations, you have to do this, because if you are adjusting it on a single link for n number of stations, there will be n into n minus links, and adjusting on all those links will be very difficult. So what should be the solution for that? The solution is that, and this is the case when we have a single LAN, right? But the solution is that we should divide the LAN into different segments, right? The LAN should be divided into different segments, and each segment should be connected with a repeater, right? And this repeater and these segments can be connected through repeaters, right? Just to balance the signal strength, because if we are talking about this particular segment, the signal strength will be sufficiently okay, it will be okay. So what should we do? We should decide that what should be the segment length, and accordingly we should divide the network, divide the LAN into different segments and connect those segments through a repeater. This repeater will be a transparent one. Transparent repeater. The stations connected to different segments may not be aware of the presence of this repeater. The stations, whatever stations are transmitting, this repeater will catch it and will regenerate it on the other side of the on the other segment, right? So in that way, the signal label can be balanced. The signal strength can be adjusted within the limits, right? Baseband and broadband transmission for bus tree topology, right? So baseband LAN uses digital signaling, as you know, and binary data to be transmitted are inserted on the cable in the form of voltage pulses. क्योंकि जो भी आपका डिजिटल सिग्नलिंग में क्या है, whatever binary data is there, it is to be inserted in the form of voltage pulses in the cable. So you can use Manchester or differential Manchester encoding schemes. So this is a bus topology, you know, this is a bus topology. So here these are the terminating resistances. The stations are connected through tap on the bus, and through the drop line they are joined over here. And this is a simple baseband where the signal travels in both the directions, right? Signals are inserted onto the bus in the form of digital signals are inserted in the form of voltage pulses on the bus, travels in the form of voltage pulses and gets absorbed at the end, at these two ends, right? Similarly, this is about the baseband cable. When I talk about broadband, broadband is of two types. One is called as a dual cable broadband, because broadband is unidirectional, right? So on the broadband, since broadband is unidirectional, how a bidirectional data transfer can be possible on a unidirectional broadband? So what we do, there is a broadband called as a dual cable broadband. So here we have two cables, right? There is a passive head end from where the cable starts. So there is one cable, okay, that receives on frequency. So the stations are connected in this way. There is another cable here. So any transmission happening on this link, on this cable, that will be done at a particular frequency. It transmits on frequency 1, and this passive head end, which is there where it changes the frequency, right? It changes the frequency, it converts the frequency. Frequency converter is there at this point. So that converted that frequency, and it is received at the, on the other cable, it is received at the other frequency, right? On the same frequency, sorry, on the same frequency. So these two cables are, there are two cables. One is this for transmission and one is for the reception, right? So this is one end of the bus, passive head end. So one cable, another cable. So transmission happens at F1 and then it goes at receives at other cable at the F1. So this is how the bidirectional data transfer is possible in case of a broadband transmission. And there is another one that is called, but this has got a disadvantage. Can you say the disadvantage of this dual cable broadband? As you can see that it is a dual cable, so the cabling requirement is high, right? So the cabling requirement is high in this case, but it depends on where exactly we have to use it, because this I will say that this split broadband, which is another one, it uses the frequency converter at the head end. So the station transmits at one frequency and then it goes to the head end where we have a frequency converter. So then that basically converts the frequency to the receiver frequency, and we receive the data at another frequency. So this head end frequency converter, this type of configuration is very costly, because this can be digital modulator, demodulator required. So frequency translator is a costly affair. So it depends on what type of, if it is a smaller plant, we can go for this dual cable broadband. But if we have to install in a larger base, then we can go for this split broadband, keeping a check and balance of the money, right? How much investment we have to do. Okay, so I'm stopping it here. Any doubt?